Okay, guys, so today we're going to be solving some exponential equations that require the use of the properties of logarithms and a calculator. Otherwise, we will not be able to solve them without ample time and lots of guessing and checking. So today we're going to use logarithms to help us solve exponential equations because you know they're very tightly related. They're inverses of each other, so their properties work together. So let's start off by just giving you the properties that we'll be using today. Our focus will mostly be on these three things here. I had originally assigned problem D on the back, but I've decided that we're not going to do that because that was more of yesterday's notes, which would require property 5 and 6. So we're not going to look at those too much. However, I do want to say this. These conditions must exist for this to be true. The conditions for these properties to be true are as follows. A, X, and Y must be positive. And A cannot equal 1. Now, in days past, I've had log base B of M and N, so I was using different variables. And the reason that I've changed it is because you have different math teachers throughout your life. They'll use different variations of these properties. So just adjust. A, X, and Y have to be positive, and the base A cannot be 1. All right, so here's what I want to do today. I just want to write out in words what these properties say, because often when I'm explaining how to solve them, I will use words to explain them. So let's write property 5 out in words. Property 5 says, if I have the log base A of X plus the log base A of Y, it's equal to the log base A of X times Y. I'm not going to say that. I'm going to say the sum of logs is equal to the log of a product. So that's the verbal explanation of that property. Property 6, you're subtracting. So I'm not going to write words over and over again. I'm going to be efficient. Ditto. The difference of logs equals the log of a quotient. Those are ditto marks. I just copy the word above so that I don't have to write them. So the difference of logs equals the log of a quotient. Property 7 is your power property, and it says this. The power times the log is equal to the log of a power. We will use this often today to get the X out of the exponential position and bring it down to this position so that we can solve for it. Okay, and then property 8 is the reverse of what we usually see property 8. Usually in property 8 we'll say if the log of a number equals the log of another number, then the numbers equal each other. Here we have if the numbers equal each other, then the logs of those numbers are also equal. So it goes like this. If two numbers are equal, then the logs of those numbers are equal. We will employ property 8 often in order to solve exponential equations. You don't have to, but it is typically a little bit easier than converting from the exponential into the logarithm and working through the process that way. Okay, and then the other thing I'm introducing to you today is the change of base formula. I'm going to move that up the screen a little bit. Change of base formula. And the reason that it's necessary is if you look at your scientific calculator, you have log and natural log. That's base 10 and base E. You don't, on those scientific calculators, have the option of picking whatever base you want. You only have two choices. So when you have a base that is not base 10 or base E, you can use the change of base formula to solve the equation. And I will illustrate that when I do method 1. I'll illustrate the change of base formula. And I'm using method 1 and method 2 to illustrate it. But anyway, here's what you do. You put the base in the bottom, base in the bottom, you know, they both start with B, so that works out. That's not really proper. You put the base in the denominator, and the log goes in the numerator. And you can choose to use common log, or you can choose to use natural log, or you can use any base you want, which is nice. And P.S., this is a really nice statement. If you can connect these two things, that's really helpful. Just so you know. You have a free response question on the test next week that's going to require you to do one of these equations without a calculator. And it's really good to know that this is the way it goes. So remember, log of the base in the denominator, log of the log in the numerator. Okay, log of the argument in the numerator. Okay, so those are the properties and the change of base formula. Again, the change of base formula is so you can use your scientific calculator to do some math. So here we go. We're going to solve this equation. Find the exact solution, exact, not approximate, exact solution of 5 to the x equals 8. And give me the 2 decimal approximation. Okay, so the strategies we know so far are when our x is in the exponent, and it's what we're solving for, what we try to do is to make each side of the equation have the same base number, but I can't make base 5 out of a base 8. I can't. So I have to go with another method. So method number 1 looks like this. 5 to the x equals 8. Okay, so I want to solve that. I'm going to have to employ my log properties or my change of base. I'm going to use log properties this time. And the log property I'm going to use is property 8 that says if two numbers are equal, then the logs of those two numbers are equal. Now, I am an efficient mathematician, and the word ln is shorter than the word log, so I will write ln instead of log. I'll use the natural log instead of the base 10 log. It doesn't matter. You can use whichever one you like. So that's property 8, right? Definitely property 8. Now, what I want to do is solve for x, but the x is up in the exponent. How do I get it down? What property of logarithms can I employ here to get the x down out of the exponential position? Power down. Property 7. So I'm all right. Okay, so that's x times the natural log of 5 equals the natural log of 8. Power down. Now I'm switching from my log properties and my exponential properties to my algebra skills. I am going to solve this equation for x. How do I do that? Oh, that's right. First, let me real quick go over here and just write that I employed property 7. That the log of a power is equal to the power times the log. So I powered down. So Joey has suggested that we divide both sides by the natural log of 5, and that is exactly what you should do. You're using your algebra skills to isolate x. So here's our exact solution. X is equal to the natural log of 8 over the natural log of 5. That is the exact solution. You could also have the log of 8 over the log of 5. In the decimal approximation, you get out your calculator, you plug it in. I need 2 decimal places. 1.29 is great. Now here's what we're going to do. We're going to make sure that our answer makes sense. So let's plug it back in just so that you're thinking about what does your answer mean. 5 to the 1.29 should approximately equal 8. You might have to round it. We did round the solution. What is it? 7.97, which rounds to 8. So that's a pretty good solution. If we went to more decimal places, we could, of course, get closer to the correct answer. So that makes sense. So that's method 1. Method 1 is done. Method 2 says this. Here we go. So let's say we have 5 to the x equals 8, and we want to come at it from another strategy. The other thing you can do is you can convert this to a logarithm. Convert this to a logarithm, because that will also get the x out of the exponent. I can say the word exponent. So this time I'm not going to be efficient. I'm going to use the log. I have to use the log because it's base 5. It's not base e. So I have to use a log. So the log base 5 of 8 equals x. So the x is out of the exponent. But how do I plug that into calculator? Calculator won't let me type in log base 5. What does it let me do instead? Use the change of base formula that says the log of what? Over the log of what? Which is what we did over here. Look, we did. We use a natural log over there, but it doesn't matter. Doesn't matter. Gives you the same answer. So there's the exact answer. Approximation is still the same. So that's the second method. And you can choose whichever you like to use. Sometimes method 1 is more more efficient. Sometimes method 2 is more efficient. It just depends on how complex the problem is. Question.
Which one do you use more often?
Which do I use? Yeah. I'm a method 1. Why? When I'm asked for the exact answer, I go method 1. If I'm asked for the decimal answer, I make decisions. Okay. But that's after multiple problems that I've solved over my life. Okay. All right. Now, here's the next 3 problems. Now, on your note page, I had not written on part C to find without a calculator. Now, here's a reason we're going to do that one without a calculator. On the test that you're going to take next week, free response, you will not have a calculator available, and you will have to solve that problem. So, the 2 on the right, on the left, A and B, you have to use a calculator or spend like an hour trying to find the exact answer. Well, probably not an hour, maybe like 10 minutes, but still a long time. But C, you can do without a calculator, okay? So first we'll do these 2, estimate the change of, using the change of base. So we want to know the log base 5 of 6 equals what? So basically, just so you know what we're trying to find, I'm going to quickly just over here in blue, you don't have to write this down. We're going, okay, 5, not in blue, I guess, in red, because my calculator didn't want to change. We're trying to figure out what power do we raise 5 to get to 6. Now, that's not a very fun, it's 5 to the 1 point something, but I don't know. So here's what we're going to do. Change of base. Log of 6 over log of 5, or if you're feeling efficient, natural log of 6 over natural log of 5. Not that it matters when you're punching buttons on the calculator. It's exactly the same. Both are equal to approximately 3 decimal places. 1.113? Yes. 28275. All right. So either one will give you the decimal approximation. So just remember, log in the numerator, base in the denominator. You can use common log or natural log, your choice. Do the next one. We're doing 9 to the what is equal to 0.2. So I'm thinking this has got to be a negative exponent. If I'm making 9 smaller, I have to raise it to a negative exponent. So natural log of 0.02 over natural log of 9? Approximately? Yes. Negative 0.73. 7, 3, 2.
27, 3, 2. Yep.
Okay, let's go to 3 decimal places because that'll get us really close.
Negative 0.
And you could have done natural log or common log. It gives you the same exact answer either way. Okay, so you don't really have a choice with those. But this next one, you can solve without a calculator, so we are going to. So how do I evaluate this without a calculator? First of all, if I go back to my definition of change of base, you'll notice in this fourth fourth equivalency, it says log of base b over log base b equals the log of x over the log of a. Log base b of x over log base b of a is the same as the log of x over the log of a. Do you see that? So, or I could do the natural log of x over the natural log of a. As long as the bases are the same, I can eliminate them. Now, I'm going to do it step by step so you can see that it's true and you can trust this because that's a lot to memorize. So I'm going to do this step by step so you can see it. So here I would use the change of base as well because I can't plug in log of base 5 of 16. I can't. So I'll do the top in blue and the bottom in red just to illustrate how I would go about solving this problem. I would do it like this. I would write my numerator as change of base. So the log of 16 over the log of 5. And then in my denominator, I'm going to grab up my red pen to illustrate that I'm going to write this in my denominator, the log of 4 over the log of 5. So I'm just using change of base. And then, if you recall, I've taught you before, if you can make your denominators the same in a complex fraction, you can throw them out. We can go, yep, we don't want that. So you can see, yes, the truth of that statement that I just pointed out of 4. Now, how do we continue to solve this so that we don't need a calculator? Because these are base 10. Here's what I suggest. I know that I can write 4 and 16 in the same base. So I can write this in its equivalent form, the log of 4 squared over the log of 4 to the first. I'm not going to put it to the first. If I want to continue solving this by hand, I'm going to power down the 2. So 2 times the log of 4, because the log of a power is the same as the power times a log, over the log of 4. Can I simplify that fraction? You know it. The answer is 2. Right? What? So I'm going to give you a challenge one. Here we go, real quick. So real quick, try this one over here on the side. Let's do the log base 3 of 125 over the log base 3 of 25. By hand, no calculator, go. I'll press. So through this method that I've explained to you, I got the answer is 3/2. So basically, if you can get this all the way down so that's the log, same base, and write the logs or your arguments in the same base, your answer will be the division of their exponents.